All right. There's your graphing motion notes. There's your joke for the day. I'll do algebra, I'll do trig. But graphing is where I draw the line. You sure did. Thank you for notes. All right. Slopes. Slopes can be either positive, negative, or zero, or undefined. What we won't use in this class is we won't use undefined slope, because in order to use undefined slope in physics, you have to time travel. So since you're not time traveling, okay, we're not going to use undefined. However, and on the side note, I filled up the candy bucket. It's full now. Okay. I got positive, negative, zero, slope. So let's do story time. Josiah, you ready for story time? Okay. Give me one person in your life. I don't care who it is. You can also make it up. That is always, like, who's somebody who's just always happy. Like, way too happy all the time. Way too much full energy. Your brother. Okay, your brother. Does your brother got long hair, short hair, no hair? Short? Is it like your hair? No? What's this? Well, we're just gonna draw Josiah's brother right here. Alright? And we're gonna give him really tall hair, because apparently that's what this means. Okay? So, what direction do positive people look? Optimistics. What direction do they always look? They always look up. So when they're climbing a hill, what direction are positive people going to look? They're going to look up the hill. So if you have a hard time thinking about positive slope, put a person on that line. As they're going to the right, are they looking up? Or are they looking down? All right, Josiah, give me somebody who's negative. Negative Nancy all the time. I don't know. All right, we're going to say you. All right, Josiah's negative all the time because we're not building rockets every day. All right, his hair's not as much, but it's definitely got some curls to it. All right, what direction are you going to look? Down. So negative slope is down. All right, now give me somebody who's like melancholy, just they're never happy, they're never sad, they're just alive. I know there's one person in class I'd point to for that. Is it be you, Spencer? Yeah. Nah, I think it's Nora. I think Nora, she's never happy, she's never sad, she's just like here. I don't think I've ever seen you smile, except for just now. Alright? Zero people. People are just there all the time. Never happy, never sad. They're just looking forward. They just want to looking forward to getting out of this class. Okay? Zero slope. We're not going to use undefined. That's because, alright, you can't time, or you have to time travel in order to do undefined slope. Cool? So when we're looking at graphs, I want you to qualitatively or look at the graph and say, is it positive, negative, or zero slope? Okay. Draw this graph. All right. I wouldn't have to necessarily include the numbers, but I would write displacement over time. All right. Displacement versus time graph. So displacement versus time graph helps you find the velocity of the object. So how do you calculate slope again? Actually, Josiah, I forgot to give you a cane. You ready? Oh, that was a right hand throw and on the money. So help me out. How do you find slope?
Rise over run.
Rise over run, absolutely. And what letter do we use for slope? M. Fantastic. So we got rise over run. Fantastic. All right, Delaney. Now these are going to be the stumper questions. You ready? What variable am I going to use for the rise? What variable is that? X or Y?
No, Y.
Y goes this way, right? Y goes up and down. Absolutely. And so on my graph, which one is Y? In that graph right there.
Wait, what?
Which one's Y?
No, wait.
That's the other B word. Not distance.
Displacement.
Displacement. Whew, man.
I have no idea.
Pulling
what
teeth. So we got displacement, which is my rise. That is what's going up and down. Piper, Anna, can you see that? That board okay? Okay. I didn't know if that was in the way. I didn't test it. Sorry. So my Y variable is my displacement. All right, Delaney, help me out with this one. Hopefully we can get it better. what is going? What's my run? What letter we use for that? We use.
I really don't know.
All right. Y goes up. Run is x.
Oh,
Follow me there. What is the x on my graph?
is it velocity?
No.
Time?
So here's my y. Here's my x. X and y. What variable?
Oh,
It's time.
I said that.
Pulling teeth. We also said like 4 other answers too. You just threw out words and hopefully you're right. It's too early. It's second period. I'm ready to roll.
No, I'm so
All right. Displacement is your rise. Run is your x. So that means d over t. Displacement over time. What formula did we use last week? That's displacement over time.
No,
Velocity. Fantastic. So that took us a while to get there.
yeah, I know.
Do we now see y in a displacement versus time graph? All right. The slope tells you velocity. Are we good there now? All right. Cade's shaking his head. Cade, you want to help me out? What are you going to do? You ready? All right. I'm going to start here at 0, 0. Okay? What am I going to do? My displacement goes, does it go positive, negative, or 0? It goes positive. So what direction am I going to walk? To the right. Fantastic. I'm going to walk to the right for 5 seconds. And then what am I going to do? Stop. Fantastic. For 10 seconds. And then we're done. So in a displacement versus time graph tells me my velocity. My velocity is positive. And then it's 0. So my velocity here, my slope, is positive. And my velocity here is 0. Not moving. Good there? All right, this is what we did last week. Let's do a refresher because I'm going to build upon it. And then for the easy stuff, all right, let's calculate the velocity for this top part right here. Well, the slope is 0, so we already said velocity is 0. Whew, that was hard. For this part right here. But now let's calculate the velocity for that first 5 seconds. Jacob, you think you got it, man?
For the first 5 seconds, would the velocity be, since the position?
How far up do I go?
25.
25?
5 seconds.
25 what?
Meters.
Meters, fantastic. Over?
5 seconds.
5 seconds. Wonderful. What's 25 divided by 5, Jacob?
5.
5. 5 what?
5 meters a second.
Meters per second. Nailed it. Cool. Looking great. Cool. What a snag. Any questions here? Because I'm about to make it tricky.
No, I'm gonna write.
So, qualitatively, you can tell me what's happening using words. Velocity's positive, we're going to the right. Velocity 0, we're stopping. Quantitatively, or with numbers, you calculate it. So the velocity is 5 meters per second, and then after the first 5 seconds, it's 0. Cool? Garrett, you good, man? You look zoned in, I'm happy. That, or you just like have me staring at the board while you're spaced out. All I'm saying is you're looking good. Cool? We good here? Questions, comments, concerns? Complaints? Okay, because if there was, go tell the guy on the slur. I don't care. Alright. Tell me what's happening in here. Qualitatively, and then quantitatively. Alright? If somebody can tell me what's happening qualitatively from beginning to end, I think I'm going to piece of chocolate for today. Hannah, you want your shot? Shot at stardom. Here we go. I'm going to start. Where am I going to start?
Alright.
0, 0. Fantastic. And then what am I going to do?
You're gonna walk to the right.
Walk to the right. And then stop. Okay. And then I'm going to walk
To the left.
to to the left, okay? Am I going to stop at 0, 0?
No.
No, I'm going to keep going. And then what am I going to do?
Now off to the right.
I'm going to go back to the right again. Where am I going to stop at?
0.
0, 0. Fantastic. Do we see that? Okay, so we went to the right. Slope is 0, so it means I stopped. Slope is negative, means I'm going left. Velocity is negative. And then velocity is positive. Stop. Good there?
Yes.
If you understand this, you're looking fantastic. Alright? Your options for candy. I don't know if I told this class yet, but I bought new candy. Spent $40 on candy this morning. So we're ready to roll. Options for chocolate or Kit Kat or Reese's peanut butter cup. Reese's. Alright. Smashes it. Now, we did it qualitatively. Now let's do it quantitatively. So here would be the question. At what time interval is the object not moving? Ella, what you got?
10 seconds. Or 10 seconds to 15.
10 seconds to 15 seconds, it's not moving. And how'd you do that?
With the line.
What'd you hear? Slope is
0.
0, which means your velocity is 0, which means it's not moving. Fantastic. If I can spell it today. Here we go. Cool. Alright. Should I give you a piece of candy or you want to keep on going for a piece of chocolate? What are you feeling? Chocolate. Alright, we're shooting for the chocolate. So, let's go. Calculate the velocity at t equals 30. Tell me what you're going to do.
Rise up or run, so it'd be the y to
You're doing great. You're just thinking through your head. Let's pick 2 points. What 2 points are you going to pick?
let's go y 20, 25.
20, 25. What would be 20, 40 you mean?
Yeah.
Okay. And then?
Negative, no, 0, 30.
Or 30, 0?
30, 0.
Okay, there we go, there we go, there we go. Okay, all right. Now, what's my rise right here? What's my rise? $40?
Yeah.
40?
It's up to 40.
40, 40 what? Meters, okay. And what's my time interval? 10? 10 what?
Seconds.
Seconds? All right. Put a piece of chocolate down on the line right now if you could tell me what we did wrong. I'll tell you, I guarantee you there's one boo-boo in here. A lot of people miss it when they're calculating slope, is they forget to do something when the slope is going downwards. Negative! What part's negative? The 40 or the 10? 40, because can you have negative time? Nope. We went down at 40. So what's my velocity here then? What's 40 divided by 10? Negative 4, fantastic. And what's my unit there? Meters per second. Okay. Oh. We're doing the Kit Kat, we're doing the Reese's. Kit Kat. I secretly wanted to give to Dallas. Alright. We good here?
Well, hold on.
Because I'm about to change gears up a whole lot.
No.
Alright? We're now going to look at a different type of graph. Going once? Going twice? Oh, one too many. Alright. If we do displacement versus time tells me velocity, what happens if I do a velocity versus time graph? That gives me the change in velocity, or some people call it acceleration. No, we haven't talked about acceleration.
Oh, no, I was in that displacement.
Nope. This is a new type of graph. This is velocity versus time. This tells me that there's a change in velocity, or there's a change in speed or direction. So let's go through this graph first. Let's do it qualitatively. All right, meaning without numbers. I'm going to start time equals 0, right here. After 1 second, Spencer, you ready? You seem zoned in. After 1 second, what's my velocity?
Meters a second.
What's that?
4 meters.
4 meters a second, okay. I thought you said it, I just couldn't quite hear you. All right? After 1 second, it's at 4 meters a second. So that means I'm going to the right. Follow me there? After 2 seconds, what is it?
8 meters a
8.
second.
So what am I going to do?
Speed up.
All right. So in a velocity versus time graph, even though this is straight, it shows me my change in speed. So it tells me that over time, I'm speeding up. So in a velocity versus time graph, if the slope is positive, we just said the object's doing what? Speeding up. Let's do speed up. There we go. Velocity versus time. If slope is negative, before I forget, Spencer, here you go, man. Let me write that just a little bit better. Velocity versus time. Slope is negative. What am I going to be doing, Garrett? If positive slope was speeding up, what do you think negative slope is going to get you?
Slowing down.
Fantastic. So that means as time goes on, I'm going to slow down or come to a stop. So, slope is negative, we're going to slow down. Fantastic. Velocity versus time graph. What happens if slope is 0? 0 zilch, nada, nothing. What am I going to be doing? Dallas, think you got it? Garrett, you ready? What a snag. Hey, you got it, Dallas? What's that? For this one right here. If slope is 0, what's your object going to be doing? You don't know? It's alright. Well, would you agree with me right here, this velocity is a positive number? As time goes on, and if I drew a straight line, would it change? No! So that tells me velocity is not speeding up or slowing down, but it is, velocity is constant. Okay? If the slope is 0, that means there's no change in speed. That means whatever I'm doing is going to be constant all the way throughout. This week's lab, what are we going to do? We're going to look at the change in velocity of an object. What causes things to change the velocity of objects when you drop them? Gravity. We're going to discover gravity this week. I've already discovered it. Well, we're going to discover the number for it. Cool? We're not doing anything quantitative with these graphs. Meaning, or at least not yet. All right, we're not doing anything quantitative. We're going to save that for later. All right, but we are going to talk about this graph qualitatively. All right, we're not going to do quantitative. We're going to save that for later. All right, let's talk about this graph qualitatively. Piper, you think you got it? Okay, I'm going to start at time equals 0. What am I going to do?
You're gonna walk to the right,
I'm going to speed up to the right, and then what am I going to do?
then stop.
Oh, is my velocity 0?
No,
No, I'm going to go what?
3.
I'm going to go constant speed, and then what am I going to do?
You're gonna stop.
Not quite. We're going to stop
Yeah.
right here. So, if you agree with me, we're going to speed up, and then we're going to be constant velocity, and then what do we just say if it's a negative slope? What am I doing?
Going down.
Slowing down, absolutely. So, the way I'm going to start is I'm going to speed up, constant speed, because the slope's there 0, and then I'm going to slow down. And then at the 3-second mark, what's my velocity?
0.
0, so then I stop. Okay? So, speed up. So we'll say velocity increases. Alright? Here, velocity is constant. You're going the same speed. And here, velocity is decreasing. Fantastic. All right. 5 leave any piece of candy. But can we do the second half of this, which can be a little tricky? You ready? At time equals 3. All right. I have stopped. What is my velocity doing there?
Stopping.
Well, I've stopped at 3. As time goes on, my velocity becomes what?
Negative.
Negative. So what direction am I going to go?
Left.
To the left. And then what am I going to do? I'm going to speed up in the negative direction. And then I'm going to stop again. Follow me there? Okay. These graphs can be a little tricky to read. Okay. I'm not going to give you like a curveball and like really trick you. All right. I just want you to read a velocity versus time graph. Here's what we're going to say for this first bit of it. So we're going to ignore the second bit of it. Okay. Speed up, constant speed, slow down, and stops. We good there? Trip, you good, man? All right. Either super zoned in or you're just spaced out. I can't tell. Are you glad we're not doing numbers on this one yet?
Yes.
Just wait. We're going to do it later. We're going to change gears, though. Let's talk about conversions. I would recommend writing these numbers down. The numbers are the important part. The roots of what they mean, not necessarily so important. And Smarties are dumb. High schoolers, have any of your science teachers taught you how to convert yet?
Yes, we have. It's been a hot second.
Oh, that?
Yeah, conversion.
Yeah.
Qualitative analysis is the true name of it, but I just call it converting.
Yeah, we did it, but it's been like a hot second.
Okay. Middle schoolers. Your 7th grade teacher? No, I just got a hard no from Wyatt. You guys didn't do any conversions in 7th grade science?
No. I think we learned this grade.
I know you had 3, but you're still supposed to learn the same stuff. You guys are just so great. One teacher couldn't hold it down.
I think we should learn it.
Alright? What I'm going to do in this class is I'm not going to do the acronym, what King Henry drank chocolate milk or something like that, and you move the decimal place, because we're going to convert stuff that doesn't follow that rule. So instead, the way we're going to do qualitative analysis applies to everything we do. So if I say a dozen eggs, immediately your mind thinks of 12. Good there, Spencer? You're super zoned in. You don't know a dozen is 12? Which means
A baker's dozen.
a baker's dozen, yeah.
That's yeah.
Mm-hmm. Baker's dozen is 13, technically. I don't know why. I'm pretty sure
Yeah,
there's
I
a
know.
history lesson on that one. But when I say a dozen, if I say a dozen eggs, you should think of 12 eggs. All right? So when I say the same thing with conversion factors between other numbers, what do those prefixes mean? So the prefix kilo, which is written as lowercase k, the word kilo literally means 1,000. So a kilometer literally means 1,000 meters. So if I were to take this, line 1,000 of them up, that would be 1 kilometer. Centi. Well, centi means hundredth. So if I were to take this, chop it into 100 pieces, one length of it would be 1/100th of a meter. So you have a centimeter. Okay. And the last one is milli, which means 1,000th. So if I were to take this meter stick and chop it up into 1,000 pieces, that means 1,000th of it is a millimeter. Okay. You're going to use these prefixes frequently. All right. The rest of the conversion factors you should know, like there's 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. The rest of the conversion factors you should just inherently know. If you made it this far in life and you don't know there's 24 hours in a day, congratulations. I don't know how you did it. But when you do your homework and when you do conversion stuff, either you're going to use these three, or you're going to use stuff you should already know. Okay, I'm not going to like pull something out of random left field. Here's examples of other ones. Look at that poster, that white poster on the right side. It says SI prefixes. There's tetra, giga, mega, kilo, hecta, deca, deci, centi, milli, micro, nano, and pico. We're only doing 3. We're not doing all those. So, please don't Google it, because Googling will get lost. Because that poster actually does a different way than we do it here. I don't like that poster in the way they set it up. I might take it in at some point. Anyways, use these frequently. These will be written on the board. I never expect to memorize them. I expect you to use them. They are tools. Alright? So let's use these tools. Convert 3 meters to centimeters. Alright, here's the process I want you to follow. I'm going to do the first one, and then somebody's going to help me out with the second and third one. Take the number you have. 3 meters, and then put it over 1. Okay? Take the number you have and put it over 1. First step, always. Always, always, always. The second step we're going to do is we're going to take whatever unit is right here that we want to cancel. See that M? And we're going to put it right down here. Always, always, always. First 2 steps. Write what number you have over 1. Second step is to take whatever unit is on the top left, put it in the bottom right. Dallas, you ready? Let me come to my house. Just you mean you want to shoot for it, or you want? What am I trying to go to, Dallas? 3 meters to? Centimeters. There we go. Now, using that reference we just wrote down in our notebook, how many centimeters are in 1 meter? So, in our notebook, it should be written down 100 centimeters equals 1 meter. If you have this little part right here, it tells you where the numbers go. All right, Dallas, ready? What number is next to centimeters? 100. So guess what I'm going to put right here? 100. Woo! All right, what number is next to meters? 1. Fantastic. That's it. All we got to do is plug and chug your calculator, and we're on our way to victory. Like, wait, Mr. Williams, I'm just going to take these numbers and multiply them, or I'm going to take these numbers and divide them. We're running into a little bit of a problem there. Number 3 is a 2-stepper. The next slide involves more units than just 1. So, before you try to find the easy way out, take one way to learn it, and it applies to everything we do. All right. I'm going to run to my calculator. Right here. Dallas, help me out. I'm going to do 3. What am I going to do? Divide by 1, sure. Times what? 100. And then we can divide by 1 again, right? So, I get 300. You get back there, Corbin? You good? Alright. Dallas, one last thing. You ready? I got some units in here that cancel out. You ready? I got a meter right here. I got a meter right here. What are those going to do? Cancel out, and what am I left with? 300 centimeters. Done deal? There we go. Cool? Not too bad. Dum Dum or Jolly Rancher, Dallas, what are you feeling? Neither? Okay. Doesn't want any candy. She wants to be sour. Okay, you ready? Try calling everybody at least once. Haven't picked on you yet. I have not.
Yeah, you did.
Did you get candy? No. That's right, I did ask you for something. Did you get candy yet? Did you want candy?
Yeah, I'll take
That's right, I did pick on. I haven't picked on Trooper yet, though. Uh-oh. Ready, Trooper? Alright. Trooper, what's the first step?
write in
Fantastic. Ah. And then I erase it. Anytime that happens where the board's not acting right, I just want everybody to know it's Radley's fault. That's what we decided last period. So, okay. 516, 15, 16 meters. What's the next step there, Trooper? Not quite, because we're not going to centimeters, we're going to kilometers. So the first thing we're going to do, we're going to take this unit and put it where? On the bottom right. Why do we want to put it on the bottom right? Absolutely, we're converted to kilometers, so the meters are going to do what? They're going to cancel out. Alright, so you already said we're going 2 kilometers. In your notebook, you should have the reference between meters to kilometers. So how many meters in a kilometer? 1,000 meters equals 1 kilometer. What number is next to the meters? 1,000. So where am I going to put 1,000 at? On bottom, next to the meters. You see that, Trooper? What number is next to kilometers? 1. Fantastic. So I'm going to punch my calculator. 15, 16. What? 1,516 meters. I can't punch in meters in my calculator. We're doing the numbers part. Multiplied by what? 1. What's that? What's that? Kilometer. Well, kilometer. I can't punch in kilometers. We're doing just the numbers part. So 1, 15, 16 times 1. What's that slash mean? Divide. Fantastic. Divide by what? 1,000. Whoop. I get 1.516. What's my units though? Kilometers, because the meters cancel out. Trooper's done with me. He's like, I'm never answering a single question again. Joke's on you. I'm going to call on you tomorrow. All right. You ready for Jolly Rancher? All right. Bunch a little bit of a problem on this next one, though. What problem did I run into? Can I go straight from millimeters to kilometers? No. But I go from millimeters to what? That's not the conversions we have. I go from millimeters to meters, and then I can go from meters to kilometers. Fantastic. There we go. So first step we're always going to do is take our number, 7,200 millimeters over 1. Why? Do you think you got it? I'm picking on everybody today. I got plenty of questions. Look at the numbers you have on your notebook. Should have these numbers. Millimeters right here. Where am I going to put millimeters at? Where am I going to put millimeters at? Bottom right. Absolutely. Millimeters. 2 meters. Fantastic. We're not done yet because I want to go to kilometers. So meters right here. Why? Where are we going to put it at? Just say the same thing again. Bottom. Fantastic. All right. We're going to go from millimeters to meters, meters to kilometers. Now, using those references we have, how many millimeters are in a meter, Wyatt?
100.
Oh, one more.
1,000.
1,000. Fantastic. Make sure you're using your reference sheet numbers. So 1,000 millimeters equals 1 meter. How many meters in a kilometer? 1,000. Fantastic. Kilo means 1,000. So in 1,000 meters, you have 1,000 meters. All right.
Yes, sir.
Elena, you ready? Calm down, everybody. You tell me what to do mathematically. You ready? You ready, White? Do no look throw. Ah, almost got there. All right. I'm gonna punch in the number 7,200. What am I gonna do here? Multiply by 1, absolutely. Multiply by 1 again, sure, we could do that. And then what about those bottom numbers? Divide by 1,000. And then divide by 1,000 again. And I get 0.0072 what? 0.0072 what? Ryan, you ready? A millimeter's gonna cancel out? Absolutely. What else is gonna cancel out? The M, the meters, right? Fantastic. And I'm left with kilometers. Fantastic. Wonderful. There's an example of a two-stepper. That's a big sucker. Ready? Do you want it? Some people don't want candy like Dallas today. Uh-oh. We good here? Any questions, comments, concerns? All right. Here's what it's saying. Don't try to learn a pattern. So we're going to use the exact same method, but now we're going to apply it to speed. All right. Notice the numbers are exactly the same, but they won't come out exactly the same. I'm trying to prove a point. Don't just move the decimal place. Sometimes it'll come out with the same number. Sometimes it won't. Ready, Shai? I'm just asking if you're ready. I'm not going to call him. All right, I'm going to do the first one. Maybe if you want to, if you're feeling it, you can do the second one. But I feel like we're going to run out of time today. So I'm going to do the first one. Don't know what time looks like. We might do the second one. You're going to do the exact same thing you did before. 3 meters, but instead of putting /HR up top, we're going to put 3 meters per hour. Ella, you ready? All right. We're going to do the exact same method, the exact same setup, using the exact same conversions, but the labels just look a little bit different. We want the meters to go out, and we want the centimeters to come in. So I'm going to do the exact same thing. I'm going to put meters down here, because we want the meters to cancel. Follow me there? But we want to go to centimeters. Go there? Cool. How many centimeters are in a meter? 100. So we're going to put 100 centimeters for 1 meter. Where do we get that number from? In our notes. Because we wrote those down. What units cancel out, Ella? Meters. And what's 3 times 100? 300. Fantastic. You can divide by 1 if you want, but it's going to change anything. What units am I left with? Centimeters. What about my hours? Per hour. We see that, folks?
Yes.
We're going to take what we did with speed and we're going to do some conversion stuff. Alright? So here's the thing I'm going to say for when it comes to your speed homework. If you do not show me your work and you ask for help, I will walk away. I won't help you. Because not only do you have to use the speed formula, but you also have to convert on top of that. If I can't figure out where you got lost easily, that means you're trying to do too much in your head or too much in the calculator. Okay? Write down your work. Question number one. Here's my work for it. Mr. Williams, did I do it right? Yes or no? And if not, I'll show you exactly where your boob is at and then move on. But if you say, hey, Mr. Williams, can I help with the homework? And you're like, where's your work at? And you're like, did it in the calculator. I can't help you. There's no way for me to help figure out where you went wrong. Okay? All right. We're going to do the last 2 tomorrow for warm-ups. The numbers will come out different. Okay? If you want to be super awesome, you can either start on the homework tonight or you can start in the pre-lab. Okay? Both are up. The lab this week is dealing with dropping some stuff.